Welcome to Quality Time with MoreSteam. I am your host, Dan Swartwout. My guest today is Xander Hathaway. Xander is the Vice President of Product Development here at MoreSteam. He studied computer science at Notre Dame and went on to earn a master's in information and data science from UC Berkeley. Xander's been at MoreSteam for nearly 5 years, and honestly, when I have questions about where software, operational excellence, and artificial intelligence all come together, Xander is the first person I call. And that's exactly what today's conversation is about. Xander is in a rare position. He knows how software gets built, he knows lean and continuous improvement, and right now he's watching both of those worlds adopt AI at the same time. What does that mean for process knowledge, for standard work, for how we know if we're actually getting better? We get into all of that in today's episode. Stick around, you're gonna like this one. And now, my conversation with Xander Hathaway. Today, we are lucky enough to be joined by Xander Hathaway, the Vice President of Product Development here at MoreSteam. Xander, welcome to the show.
Thanks, Dan. It's great to be here.
It is great to have you here, and they say that good things come in threes. We have 3 high school valedictorians here at MoreSteam. You are the third one to be on the show, so 3 of 3 to be on the show. And we have 3 Hathaways here at MoreSteam, and you are the third of 3 to be on the show. We're excited to have you here today, Xander. Thank you for joining us. You've been at MoreSteam now for almost 5 years. Vice President of Product Development, very heavily involved in the engineering of the software by MoreSteam, but you're also very much involved in lean, in operational excellence, and you're really near the forefront or at the forefront of artificial intelligence and AI. And obviously that has been a huge topic in just the entire world over the last few years. And I really want to talk about it because you are in a unique position to know software engineering, to know operational excellence and Lean Six Sigma, and to know AI and how they all intersect. Before I ask you some specific questions, do you have any general statements about the intersection of those fields and where we're at in 2026?
Well, I feel like there's a lot of overlap. Maybe some people who don't feel this way about IT, but I do feel like software engineering just naturally has a ton of overlap with a lot of principles of operational excellence. If nothing else, writing code a lot of times you're just designing a process. Now, maybe it's a computer who's carrying out that process, whether it be moving information from one place to another or performing some kind of task. But ultimately, if you're writing code, a lot of what you're doing is you're writing processes. And so, I mean, some of the first things you learn about are the costs of those processes, whether it be time complexity of running certain code or space complexity for how you're managing information and memory and things like that. Like these things have very natural parallels, I think, to other parts of the OpEx space. And so I think I think a lot of software engineers are very used to designing processes and feeling what it's like to be on the receiving end of processes. Maybe the small difference I see or a unique part of software engineering is that you're not like the computer oftentimes is running the same code and it's just running the same thing over and over again. And so the process improvement comes from how do you get better at designing processes? How do you get better at writing code? And so I feel like that's like a fun meta level where the challenges are always new. You're not, producing the same widget every time. Like there's a lot of inventing going on that I really enjoy. And so it's a really good challenge and a never ending one for trying to figure out how to build software better. And I think there's a lot we can learn both from the lean side of things and the OpEx side of things for how we can build software better. And I think that's something we're trying to do here at MoreSteam, but then also there's a lot to be learned from some of the things that people are figuring out, especially in like a very tech native world with the way that the world is going with the reliance on data and AI and computers and things like that. I think there's a lot that the a lot of ways we have to lean into what the software engineering world is doing, especially when it comes to things like AI agents and stuff like that. There's a lot of people who are really pushing boundaries over there, and I'm really excited to see how we can bring some of that into the OpEx space.
Lean has always emphasized, Xander, going to where the work happens to understand it, going to the Gemba. What does that look like in software development where the work isn't physical? How do you go to the Gemba in software development?
Well, maybe you can't walk somewhere, but I think the first thing that comes to mind is being in a code base is certainly unlike anything else, and reading code and understanding build systems, understanding how code goes from something comes from an idea and makes its way into code and is shipped into production and all the steps along the way. Like, it's a little more virtual, but there's still a lot you can go and look and see. And I think that there's a lot of challenges that people find when, the reading a code base isn't something that's accessible for everybody. Right. And I think that's where a lot of conflict comes from, is you have software engineering saying one thing, like, hey, we're running into these problems. We really need to fix this thing. There's this tech debt. And it's really hard for people on the other side to understand, like, how much does this matter? The system seems fine. There's a lot of conflict there that I feel like I've seen in my career. And so I'm very partial to, I think going to the code base, at least talking to the engineers who are working on the code base is super important for understanding the health of the system and kind of looking forward for what the health of the system is going to be as you continue working on it.
Now we're going to dive into a little more AI. We've set the table. We've talked about software development, the lean aspects of it. We've touched on AI a little bit. One of the promises of AI-assisted development is that you can produce software faster than ever. I read an article recently that the number of apps in the iPhone App Store has exploded as people have been able to use AI to assist them in coding. From a lean perspective, what's the difference between simply moving faster and actually improving the process?
There's a lot of different applications. There's a lot of different use cases. And what I would say is a lot of times more lines of code does not necessarily make something better. Just having more of something doesn't make it better. It can make it convoluted. It can introduce complexity that's unnecessary. And so I think all the principles about design and simplicity still matter a lot. I think where maybe there's a bimodal distribution is there's certain places where being able to write code really fast with the use of these AI agents is going to unlock a lot of people who maybe they're not code first folks, but they're able to program something to do a small task that has been really annoying or manual or whatever. It's awesome to unblock those people and see innovation in that kind of space. But then also I think, like, with more mature, larger software applications, writing code is just one step of the process. And I've always felt like every line of code is kind of like a bug. Every sentence, if you're thinking about writing, Dan, like you're like a legal brief or whatever it may be, like every sentence is something you can nitpick in it that you don't like, or the wording could be different, or that you go back and read it 3 years from now and you think, oh, I can't believe why did I write it like that? Like, those things all still apply. And so I think there's still a lot of judicious judgment that needs to be applied. And also, writing code is just one step of the process. Like, building the right thing is still way more important than how you build it. And so there's certainly use cases for AI there, but I wouldn't want to over-index on just the code writing portion.
In manufacturing, Xander, we've seen what happens when organizations optimize output metrics without really understanding the underlying process. Do you think software teams are at risk of repeating that pattern with AI?
Yeah, I mean, this has been a problem with software teams since before AI, of trying to figure out what are the right metrics for evaluating the health of a team and output. And it's really hard. And there's a lot of metrics out there, things like number of lines of code written, which are just terrible metrics. Activity does not mean, value. And so it's getting a lot easier to write a lot of code. But writing a lot of code doesn't mean that you're actually solving the right problems for a customer, that you're making your software easier to use, that you're making it more maintainable. So yeah, I think there's a million metrics out there, even things like velocity, how many points were done in a sprint. they all have to be taken with a grain of salt because they're proxies. They're approximations of reality. And I think the same things that we've been fighting with for years about not over-indexing on metrics still have to apply, and we can't lose our judgment there.
One of the things that's very interesting about AI is the idea that Lean puts a lot of emphasis on standard work with good reason, that the processes don't live in the mind of one individual who, if they're absent that day or leaves the organization, all of a sudden our work is gone. We don't know what to do. So you have that standard work in place. How does the idea of using AI to help generate code interact with the idea of standard work?
I'm so excited about this. There's so many great applications for this. For a long time in software engineering, there's been simple tools, build tools, linting tools, things to make sure that your code is styled appropriately. But there's such a large problem space for how a certain problem should be solved, where, traditionally there's a natural back and forth of somebody building something, there's peer review, there's design up front, and these things kind of circle back and forth. And it's been really hard to enforce standards for how you should build something or instructions for how you should build something, because a lot of software engineering, it ends up sounding kind of philosophical for like, hey, we should try to use a little more functional programming in this, right? Like you're relying on state too much, without getting too much into dolphin talk, like let's really think about how you could rewrite this function to be whatever it is, blah, 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 blah. Those are really hard instructions to get, to write down and give. It's a hard practice. It's engineering, right? But I think that there's all these great use cases where we're going to be able to start giving AI agents these kind of higher level, I don't want to say philosophical, but these higher level instructions for, hey, when we're doing this kind of feature, I want you to keep in mind these key principles. And they're able to translate those higher level principles into the code base, and you're able to have really rich dialogue with these AI agents about, here's the thing I'm building, and does this align our team principles? It's very common these days with AI agents that half the battle is, how are we giving the best instructions possible for the AI agents to follow? That's just standard work. Like everybody's embedding these files in their code bases for Claude or Codex or whatever it may be, to help instruct those AI agents on how it should be performing and what kinds of code it should be writing and all these different things. And all those instructions are great for people too, and forcing people to think about what kinds of instructions and standard work people should be following in their repositories or in their code bases. It's probably stuff that we could have been spending more time on as an engineering discipline, before these AI coding agents. But it's become more of a necessity as we're able to kind of like grow the amount of lines of code written. Like we want to be particular about the type of code that's being written. And so thus there's this whole new flood of effort going into writing standard work for how we code. It's really exciting. And the other thing is it's an evolving field where it feels like it keeps changing every week. And so I think that's the other hard part of this, is figuring out the standard work for writing standard work is constantly changing in the software engineering discipline. And so it's exciting time.
It's got to be exciting for you, being the vice president of product development here at MoreSteam. You are really and the organization as a whole is in two worlds. It's in the continuous improvement and operational excellence world, and it's also in the technology world. And we're watching both worlds adopt AI at the same time, technology and OpEx. What patterns are you noticing that most people in either world, maybe they're not talking about it yet?
I think it would be fair to say that software engineering, something about the discipline lends itself well, particularly to these large language models. Code is easily understood by these large language models. And I think part of the reason why we're seeing such adoption in the software engineering space is because there's so much context and written instruction for how things work. And I think it would be fair to say that there's a lot of places in a business and operations where things are not written down in the same way as they are in a code base. because in a code base, we are already having to tell, a machine, hey, here's what you need to do. We've already been writing instructions for years and years and years. And so I think it highlights the importance of how are you able to make information more readily available. Like if you're, the data out is only as good as the data in. And so I think it highlights the importance of making information available to people and AI agents. And I think this is something people really struggle with, especially with IT, is getting the right data, but it's also getting the right instructions, getting things written down, getting things out of people's head. That's such a challenging task, but it's clear that on the other side of that, if we're able to get the right information in the right context, that we're able to unlock a whole bunch of other activities that are going to be enabled by these AI agents. But still the limiting factor here in a lot of these places, especially that are not code bases, is going to be the information that we provide. And so I think that's going to be, that's been a challenge for years. I don't think that's going to be solved immediately tomorrow. There just might be continued pressure to try to figure out how to do that better within an organization.
I want to talk a little bit about hallucinations and AI hallucinations.
Yeah.
In the legal world, we've been hearing a lot about briefs that are being filed with made up cases. And I think anyone who has used AI for a decent length of time has seen AI just flat out say something that's completely incorrect with 100% confidence in what they're saying. So how does that ever play into, and how can you use continuous improvement principles to weed out those hallucinations when you're using AI to help develop code?
Yeah.
Is this you're always going to need people for some of these things, right?
Yeah. And you know who else confidently says things that are wrong?
People.
So like, don't get me wrong. I don't mean to undersell the importance here, but it goes back to the level of effort we put into our system design and building systems that are fault tolerant, that are resilient to errors, is crucially important. And I think, on the coding side of things, one of the most useful things to do for hallucinations, if you will, is building in automated tests, building in ways for these coding agents to check themselves, to say, hey, I think this is the right answer, but you build in that verification system. You build in that loop to say, like, is this correct? Am I on the right track? No? Okay, I need to readjust. And having that feedback loop as early as possible, I don't think that's a new idea, having shorter feedback loops. That's going to be applicable in any part of the world. So I think obviously these model providers are trying to reduce hallucinations and get better at this, but it's also our prerogative to build in support for measuring the hallucinations and measuring the efficacy of these systems, and not putting that all on the model providers to fix, to just say, oh, well, ChatGPT hallucinated this thing, so I can't trust it at all. It's like, okay, maybe that's true. Or maybe there's ways you need to design the system to make it more fault tolerant, and understand, being able to measure just what's my, my acceptance level for some hallucinations. Because there's going to be certain situations where you say, I will take a small amount of hallucinations for X amount of benefit. And there's going to be other situations where you say, I can accept 0 hallucinations. And so you're going to need to think about, and what kind of type 1 or type 2 errors am I okay with? And for every situation, design your system accordingly. You can't make up case law with ChatGPT. That's unacceptable. But there's other situations where, small errors are not going to be a problem. So a lot of it is just assessing the situation that you're in and deciding what level of error is acceptable, and then how am I measuring that error, and how am I trying to, systematically improve it.
That gets back to one of the fundamental principles of process improvement, Lean Six Sigma. 99.5% may be really good in fulfilling an order at a restaurant, but that's terrible for building an airplane.
Yeah. And so it's up to all of, everybody should know in their process, what's my fault tolerance? And again, I don't think that's new to AI. It just might have a little more of a spotlight on it. But
thanks, Xander. You've given me a lot to think about. And I have determined that my fault tolerance is 0% when it comes to not including this short break. MoreSteam's enterprise process improvement platform includes the tools, training, and software you need to transform your organization into a problem-solving powerhouse. Join the ranks of Fortune 500 companies that trust MoreSteam for their enterprise process improvement. Visit moresteam.com to learn more. Also, I want to take just a moment to thank you for listening to Quality Time with MoreSteam. You can email the show at qualitytime@moresteam.com. And if you're enjoying the show, please leave a rating or review on your favorite podcast service. And now back to my conversation with Xander Hathaway. As a software engineer, I'm sure you can appreciate that software systems tend to get more complex over time, and complexity has a way of hiding problems until they become expensive. So how do you think about managing that in a world where AI makes it really easy to keep adding to a system?
Yeah, that's a great question. I don't know that we totally know the answer yet, because I think that, and I think in any of this, anybody who's too confident about their answers and how AI is going to affect these kinds of systems doesn't really know. I have a few thoughts on this. One, there's a possibility that, maybe the AI systems get so good that they're able to, like any debt that they incur of adding complexity in the short run, they're able to kind of pay off that debt with better capability in the future. That's behind door number one, which feels a little irresponsible to just bet that the models are just going to get better and better and better to just fix any kind of complexity debt that you add into your system. I guess that's one possibility. But the other is, I think, complexity is like a bug, in my opinion. And there's a book called The Pragmatic Programmer, and they use this. The author uses this metaphor of broken windows, and this idea that, like, if you're constantly walking past broken windows, does it allow kind of the neighborhood to degrade over the time, or is there like a complacency with a certain level of quality? And in a real social situation, that's a little bit more of a complex topic. But in a code base, there's something to that. If I constantly walk past this complexity, this ugly complexity, ugly code, ugly process, whatever it is, it's like that does become a cultural thing to figure out what kinds of messiness do I accept as a team. And it's a hard balance, because there's some places where you say, hey, you know what? Trying to gold plate this thing and make it perfect, there's not ROI there. And that's a hard trade-off to make. But in general, as a team, I think it's really important that can be a slippery slope. And, as my brother says, a slippery slope is only slippery if you let it be. But I think that's something that teams are going to have to be aware of, is how much complexity are they willing to endure, and does that impact culturally the quality of work in the future? I don't know what the answer is going to be there, but I suspect it's going to be uneven across teams.
I have to ask, when you were at Notre Dame, obviously one of the finest colleges in the country, UC Berkeley, again, one of the finest colleges, universities in the country, you're there about 10 years ago, 15 years ago. How often were they talking about AI back then? And how realistic is what they were talking about looking into the future? How realistic has that become with what you see now versus what they were talking about while you were learning at some of the finest institutions in the country?
I don't remember much of it in undergrad. There were bits of it. I always loved natural language processing, NLP. That was something I did a little bit in undergrad, and that was a big reason why I wanted to go back to grad school. And that's like the discipline from which large language models were born. And so not a lot in undergrad. And then at Berkeley, when I was in school, I remember playing with GPT-3, and that was a big deal. And dealing with and playing with some of the newer language models coming out of Google. And I remember reading the Transformer paper, which was like a seminal paper that's unlocked a lot of the large language model work. Attention is all you need. I remember we learned all of that, but the rate at which it exploded and got better was unbelievable. Like I just think about the quality and the ability of those systems. Like a lot of the concepts are very similar, but they just took such a step function change so quickly, where so many assumptions or things that I learned even in grad school not that long ago, I don't know how long ago, 5-7 years ago, are almost like obsolete. Like principles are still there, but the expectations of these systems it's just a completely different thing. And so if nothing else, the learning there is that the rate of change is so high that it demands a significant investment in learning about everything that's coming up and everything that's coming out in the world and things that people are trying. Because, man, there are so many amazing people out there who are so curious and inventive. And I almost feel like we have like an obligation to pay attention to all these great things that people are trying, because otherwise we're gonna miss out on exciting stuff that's coming out.
I'm glad you talked about the rapid rate of improvement, because that leads right into my next question. If AI tools keep improving at their current pace, do you think some of the traditional arguments for deep process knowledge become less important, or do they become more important?
I have a hard time believing they'll be less important. Maybe computers can make things seem like they go fast, but I would reframe this to say, if there's so much information available at people's fingertips, the flip side of this is, if I'm new in this field, if I'm in the process improvement field, if I've been doing this for 25 years, I might have some battle scars or things that took me a long time to learn, whether they be things in theory or in practice. And maybe there's an opportunity there where if I'm just starting out and I'm trying to solve a problem, like the scientific method is undefeated, but sometimes if you can't come up with that next hypothesis, it's really hard to go through the next set of steps in that scientific method. And so if that's all that problem solving is, I think my hope is that, something like deep process knowledge is like, it just gives people an opportunity to brainstorm more with these AI agents, check some ideas out, and maybe best case scenario, we shrink the gap between starting on a problem and being able to solve it. Hopefully that's still, we make sure that we're still engaging a lot of our critical thinking skills, and that we're not kind of punting on our self-judgment for whether or not an idea is good or not, because that seems like it'll still be important. But I think if anything else, again, going back to this idea of lowering the barrier to entry, maybe some of it is we can lower the barrier to entry for this practice and the theory of how we do process improvement.
Xander, for a CI leader with no software background who's watching their organization adopt AI tools rapidly, what's the most important thing you'd want them to understand going into that?
I think these tools are really powerful. They also don't do everything. I think it's easy to, depending on where you stand, to point at a place where the AI tools are not applicable and say, I don't know if these are useful. And that's the case with any tool. They're not helpful in every single situation. And so I think you got to be curious. And I think continuing to stay up to date on that jagged edge of capability of like, what are these good, what is the new AI technology good at and what is it not? Because otherwise I think you're just going to get trapped in this world of not understanding when it's the right time to reach for these tools, or maybe having false confidence in the tools, or you missing out on the tool's capabilities because you were annoyed it couldn't do something else, right? Like it can't make a picture of a clock that displays, the time being 10:40 instead of 10:10, but I don't know if you guys have seen this, but every single clock that's on the internet looks like it's at 10:10, right? It's just a good looking clock. But that's not indicative of whether or not it can write really sophisticated code. And that's a hard thing to square. And so I think being curious and trying to, as best we can, keep an understanding of the capabilities and where that frontier lies is crucially important.
Or you tend to see the AI pictures of people with 3 arms. You're like, oh, well, what happened there? How is this a third arm?
Well, I think there's also like a sports analogy here where like, hey, if we're talking about, the Raiders, whoever it is, like it's easy to talk about, hey, here's what a player can't do. But like you don't build a team talking about what a player can't do. You build a team by figuring out, well, what can they do? How do we put them in a position to succeed? Right? How do we draw up the right plays for that person? How do we surround them with the right personnel? So I think you got to flip the attitude from not what can we not do, but well, where can we use this? And I think that's a better disposition to have toward it.
Xander, as a Raiders fan, I don't know whether to be offended that you used the Raiders to talk about what players can't do. I don't know how I should take that.
No comment. No comment.
Xander, this has been a fascinating conversation, and I want to close with maybe you could tell me how we could use AI to determine the statistical odds of this scenario, because even 9 months later, I'm still floored. We had a MoreSteam outing to see the Columbus Clippers baseball team, which is the AAA affiliate for the Cleveland Guardians right here in Columbus, Ohio. And your youngest child and me, we share a birthday, same birthday. And then Allison, our VP of Finance, her husband also shares that birthday. So at that Clippers game, through random chance, we had your child, me, and Allison's husband, 3 seats in a row with 3 people who share the same birthday. It still blows my mind. It blew my mind right then and there. What are the odds in a baseball stadium that 3 people share the same birthday sitting right next to each other? And it wasn't like, hey, it's your birthday day at the baseball stadium. So how can we use AI to determine the odds of that?
Boy, it seemed like low odds to me. Maybe this isn't the answer you're looking for, but I actually think this is a good segue from the jagged frontier, and it's worth calling out. Like, when we say AI, it's such a broad term, and it's actually just, there's a lot of math and statistics it's not built for. Those are deterministic mathematical functions that AI is not quite geared to handle at this time, right? At least not without the help of a lot of other tools doing the work for them. And so I actually think this is a great example of like, I would never use AI for that question. Maybe I'd ask it for how to solve the problem or how should I think about framing this problem, but I wouldn't expect it to actually do the math for me. So that's a great example of understanding the difference between when do I get how knowledge versus like execution knowledge out of an AI system.
Well, here's what I'm going to do, Xander. I'm going to leave a little bit of a cliffhanger for our listeners. Between this episode and a future episode, I will talk to our company statistician, Thomas, and have him help me determine the odds. And then we can present that in a future episode so you can know what the odds are of 3 people who share the same birthday sitting right next to each other, 3 in a row at a baseball stadium on a random night.
Well, and I think the important thing we're missing out is it's also Pi Day, which I think has an extra layer of mathematical fun to it, if you will.
It does add some more mathematical fun. AI wouldn't have made that observation, Xander. There's the jagged edge again.
Well, hey, Dan, thanks for having me. I really appreciate it. Enjoy chatting with you.
Thank you so much. This has been absolutely fascinating. Our AI episodes in the past have been some of our most popular episodes, some of the most downloaded episodes, and I know this one will be right there, up there with those. So thank you so much, Xander. This has been fascinating. I know we'll have you on the show again sometime in the future. And hopefully, whatever it is, you're not the third one as a guest, as you were third valedictorian, third Hathaway.
Thanks, Dan.
But good things come in 3. Good things come in 3.
That's right.
Thank you, Xander.
Cheers.
We'll be back in 2 weeks with another episode of Quality Time with MoreSteam. Thanks again.